Mean to. So some of you are working on the exam, and that's super fantastic that you are. I totally appreciate that you're getting into it early. It's all about grade. I mean, honestly, the exam is pretty much all grade. Because I wanted to err on the side of caution. We could have put linear regressions on there, probably even quadratic regressions, which we're going to get into today. But I said, you know what, why rush to put it on there? We can wait till the last one to put that on there. There's no reason you have to have it all on one exam. So that's why I just focused on grade, and I tried to find some neat applications of grade for you guys to use. But there's no submission link for it yet. So I didn't plan on anybody being done yet. So I was gonna load the link on Friday, because usually when I have my Outlook ADD, I have my Outlook calendar, bing, every Friday and says update your Blackboard submissions. So every Friday is when you'll see the links show up that you can actually submit stuff for the following week on. So you can still work on it, of course. Everything's active. You can download the document, watch the video that's tied to it. There's no spreadsheet, I don't think, attached to this one. So yeah, I mean, you can get all the resources you need. You just can't actually submit it when it's finished. So, sorry, didn't mean to freak anybody out. Tiffany, I was going to say Tammy. I had the first and last letter right-ish. First and last sound. Tiffany asked a phenomenal question related to the exam. And I want to make sure that it's tied to what we're doing today, too, which is pretty badass. Tell me what your question was again.
To find the average grade, do you take the first and the last? Or do you take all the percentages, add them together, and then divide them by the question?
Such a good question. Such a good question. So the question is, she's talking about average grade, and we're going to look at something called average rate of change today, and it's all about the idea of an average, because I love the idea of averaging, and when you shouldn't use it, how to do it correctly, how to avoid doing it incorrectly, and this is such a good question that ties into all of that. So the question of average, I want to draw a kind of similar profile to what my commute is that you guys are analyzing on the exam. So if you actually come down, you start up here at, no, I don't start at Grandview, I start at Glassell. And then I drop in very steeply on Powell. I'm going to exaggerate the steepness. The road isn't actually that steep. It feels like that when the car almost hits it. And then I get on to Iowa. And then I cruise on Iowa. It drops a little bit, and then it drops down to, I think that's called like Evergreen or something. And then it comes down and crosses Juniper. Then it begins to flatten out. It looks kind of like that. Now, it's not that linear either. The road doesn't go in straight lines like that, otherwise you'd bottom your car out when you hit them. I mean, they do change. I mean, they do things like this, and they do like that. You know, so, I mean, this is pretty much like a rough idea. All I had you do was take grade snapshots at different points along there. Just points where I'm like, that looks interesting, and I took my phone and I shot an elevation right there. And then I shot an elevation, then I shot an elevation. So I took like what I thought were interesting stopping points. I made sure to hit right above and right below the steepest part. If you're watching the video, it's where the guys with the street signs are. I was planning on running that stop sign, but they do the street signs, and I'm like, I'm gonna die, I better stop. So I definitely shot those. And then I shot somewhere down here, and I think I shot at the very end. I shot at the very beginning, I know that, it was right about here. And I think I shot somewhere, I forget how many exactly there are. 7 altogether, so I got 6 of them marked there, so somewhere in there I got another one. Great question is, why can't I just figure out, we'll call this grade 1, grade 2, grade 3, grade 4, grade 5, grade 6, and let's put one here and call it grade 7. Why can't, to find the average grade, I just go grade 1 plus grade 2 plus grade 3 plus grade grade 7 and divide by 7? Why can't I do that? That is such a good question. And probably the hardest question I've asked you yet in this class. And I wasn't planning on asking it today. So there you go. Why can't you do that? Why can't you do that? Any idea? Well, so I should say that. Sometimes you can do that. But why can't you do it in general? I guess we should do with that.
Morlocks will attack you if you do it.
Say that again?
The Morlocks will attack you if you do it.
What is a Morlock?
Have you ever read The Time Machine?
No.
By H.G.
By H.G. Wells.
You should read it.
I just saw that really bad movie with, what's his name?
Oh.
Guy Pearce.
Don't avoid my question!
Because you're averaging the rate of change through different
Okay, so listen.
You're averaging your rate of change through like each section.
Why is that bad? Why is that bad?
Because you're not going from A to B, you're going from A to B to C.
Okay, and between, say, A and B, what else is there? Isn't there something else going on potentially there? Let me ask you a different question. Related to this, but you might not see how. You guys have a GPA, or you will after this term, if you don't have one yet, this might be your first term at COCC, you might not have one yet, but you probably had one somewhere. How do you get that? How do they calculate, I shouldn't say that, how do you get that? Get that by going to class. How do they calculate that, Amy?
Your grade for how many credits you're taking.
See, when you get a grade in a class, you get an A or a B or a C, that has like a numerical equivalent. You know, we ripped this apart in 243. Like, I make the kids sit down and look at every little nut and bolt of this calculation. But an A is a 4, a B is a 3, an A minus is a 3.67, a C plus is a 2.33. So suppose, you know, you get, you know, an A, a C plus, I don't know, a B. Let's just start with that. Okay? That A has a number of a 4, that C plus has a number of a 2, 3, 3, and this B has a number of a 3. So what would this student's GPA be? Can we just go 4 plus 2.33 plus 3, 7, 9.33 divided by 3 is going to be 3.11. Can we do that?
Because they're weighted different.
We can, but we can't do it all the time. When's the only way it would be legit to do that?
At the end of the term.
No, not necessarily though, not necessarily. Michael, right?
Class had the exact number of credits.
If each class was worth the same number of credits. So if this were Math 105, Psych 201, and what's something else 4 credits? Writing 121. You could do this. Technically it wouldn't be this divided by 3, it would be 12 times this divided by 12, or whatever that, 4 times this divided by 12 would be the same thing mathematically. But if this were total fit, which only counts as 1 credit, hardest 1 credit you're going to take, and if this were, say, a bio lab class that had 5 credits, and this were, I don't know, a writing class that had 4 credits, your GPA would not be 3.11, it would be lower, because the 2.33 is worth 5 times as much as the 4 is. So you'd have to do 4 times 1 plus 2.33 times 5 plus 3 times 4, and divide all of that by this number 10 here, because you have 10 total credits. So related to that, Tiffany, is the average grade. The grades aren't worth the same amount because I haven't specified where I shot them from. They weren't at uniform intervals. If I took instantaneous grades, which meant the entire time, I'm doing grade calculations the whole way down, every instantaneous change, you could do that, but because I took them basically at random, you can't assume that every grade is worth the same as every other grade, because, for example, the one you calculated right here is very steep, but it's a very short part of the road. It's a very, very short part of the road. Whereas the one that's down here is extraordinarily, you know, shallow, but it's a long part of the road. When you said, say that again.
Is it because the run changes, like the distance from?
It's because the steepness, the grades themselves change. I mean,
Right.
if you stand, did anybody know Iowa Street that we're talking about on the exam? You know what street I'm talking about? If you get a chance, just go up. It's, if you're on Portland, turn north up 9th. Okay, and then you'll pass a park on your left called, I think it's called Hillside Park, I think.
Yeah.
And then it turns into Trenton. This is such a weird thing that Ben does. 9th becomes Trenton, and then it becomes 12th. It's all the same road. As an East Coaster, it pisses me off. But then, once you're on 12th Street, look for the big teepee. There's a dude that has a huge teepee in his front yard.
Oh.
Take a left, that's Iowa. Just look. And when you look at it, it's like, oh my God, it's a cliff. Because you're looking at it, and the road does that. But all you're looking at is that part of it. You're ignoring all of this, which is pretty shallow. I mean, you can cruise along that on a bike pretty well. As soon as you hit that, that's when the heart rate goes through the roof. But then it levels off again. But that one part, that super steep section, is only a tiny, insignificant little part of the overall road, which is why it doesn't count for much in the overall grade calculation. Fair? You saw the same thing if you did the quiz on my commute a couple weeks ago, or it was last week, it might have been last week, the commute quiz, where I analyzed, you know, my overall grade for my commute. And it was very, very shallow. It was like 2%. I mean, it wasn't very much. If you see my commute, you think I'm out of my mind. How is that 2%? He's going up the side of Aubrey Butte through a trail. That's because at that one section, it's amazingly steep, and it's got 2 huge switchbacks, boop, where the quiz idea came from, 2 huge switchbacks to break up the grade. But then there's one section where I'm actually going downhill. I'm still picking up run, but I'm going downhill, which means I'm losing rise. Right? And the very last thing I do on that commute is drop in and lose more rise. But I'm still picking up run. So if I'm losing rise but still picking up run, my grade has to be going down. that doesn't mean at one section of that, I'm not going what seems like upside of a cliff, but it evens out. That's why when you do the average grade, just look, where were you here and where were you there? How much run did you cover and how much rise did you drop? That's your average grade. It ignores all the ins and outs. I'm not saying that's a good thing. It's situationally. For example, if you want to tell somebody I was fly fishing on Sunday morning, early Sunday morning, beautiful sunrise Sunday morning, nobody saw that. Just stupidly beautiful sunrise Sunday morning. And right after sunrise, we're out there in the river fishing, and my friend is like, yo, how deep is it? And I had to make sure I answered that. Because you can say, it's about 2 foot on average. I said, no, right there's a hole and it drops to 6. Now, I was right by saying it's about 2 foot on average, because most of the time when I'm walking around, it's up to about my knee, a little bit higher. But you can drown in 2 foot average water if it's 3 inches, 3 inches, 3 inches, 3 inches, 3 inches, 18 feet, 3 inches, 3 inches, 3 inches. That averages to 2 feet, right? But it might not be the fairest or safest thing to talk about. Much like if I was talking to somebody about a commute, oh, dude, it's a totally legit commute. It's 2% grade. If one of my biking friends was talking to me, and then I sent him up Aubrey Butte, and he said, what's wrong with you? Seriously? Please.
If you're going downhill, is the grade negative?
Technically speaking, yes. I don't care if you call it positive or negative, though, because it's all referential to how you're going, up or downhill. Great question. Is downgrade negative mathematically? Yes. But as long as if you say it's 6% downhill, I know what you're talking about. So we're happy with that. Yeah. And you'll never see a negative grade on a sign. But you may have noticed that. It shows the truck going down. It's always 6%. It's not -6. It should be -6 because they're dropping. They don't give trucks the warning going uphill. All they say is slower traffic, keep right. Because that's when the trucks have to slow down and get on the right side. But yeah, that's like a math point that I'm not too worried about. Christina?
So, when I was doing my exam, I was thinking, when you're doing the last part where it's the full...
The full thing, yes.
Yeah.
Don't overthink it.
No, but what I'm thinking is if you make it into the triangle, the run is a lot longer.
Yes!
Is that right? Okay,
Yes, that's exactly what you have to think of it as. When you do the average rate of the whole trip, you forget the topography of the intermediate pieces,
Right.
and you essentially do that.
Right.
That's all you're doing.
That's what I was thinking.
And that's why it can be misleading. If you tell your friends whatever that grade ends up being, let's say it's 4%.
Yeah.
It's 4%. Yeah, but if it does this, to get to that 4%, you might want to rethink it's 4%, but it oscillates a whole buttload. It's as much as 20 and as little as -20.
Is it that the run, I mean, like when you're doing just the from point to point average, that's a shorter run, so that's gonna...
But it's still an average, right? Isn't it still an average grade over that run?
Yeah.
Or over that distance? It's still an average. It's just the overall average ignores all those individual pieces average, which comes full circle to Tiffany's question.
Okay.
Which was such a good question. See, it ties into today. If I may, did I answer your question, Christine? Did your question answered satisfactorily? Ask it again. Ask something else then. Let me keep going.
Well, I guess what I was when I was looking at it, I was thinking, here's this, when looking at the shorter triangles in between, those are shorter runs, and then but you triple or quadruple it when you do the whole.
You do.
So
and
it's going to be a bigger or a smaller number.
It kind of depends on how much you rise and fall, right?
Right.
I mean, you can make I used to have students do this, but they didn't like it too much. I used to have them draw a road where, at one section of the road, the grade is insanely steep, but over the entire trip, the grade shrinks to 5%. They were like, I get what you want me to do, but I don't like this question. I used to also take an elevation shot. Has anybody ever ridden their bike over Mackenzie Pass? Or taken the car over Mackenzie Pass? It's wonderful, right? Especially this time of year, it's gorgeous, changing the colors. So I took a GPS, put it in my back pocket, and rode up and over and back. And the shot of that, the elevation chart of that is just gorgeous. And then I had kids analyze it, like, never do that again. I never want to do that again because it's so micromanagerial. And I told them, like, no, average grade. Where was my highest? Where was my lowest? They're like, I don't care what you're saying. It was like too much to process. It was like too much to look at. If you looked at the extra resources for linear modeling, you might not have done that. That's totally fine if you didn't. There's an elevation shot of my my Aubrey Butte running that I do sometimes with part of Total Fit, up and down Aubrey Butte, and you look at this and it's like, and I say, what's my average grade? It's 0, because I started at my house and I ended at my house. I didn't go anywhere. If you ignore everything in between, my average grade is 0. I ended up back at my driveway on my bike. 16 miles later, exhausted, hungry, but my average grade was 0 because I gained no overall elevation. But you see how that's misleading. So then I had to micromanage. Okay, how about on one of the triangles, what was my average grade? Oh, okay, from just the uphill to the downhill part, which is what you're doing here. And this, I think students actually get, because it's small, it's technical enough to practice the grade, but it's also not so macro to micro that it pisses people off. That's what I'm trying to avoid doing, is pissing people off mathematically. Math does that on its own pretty well. Cool? Tiffany, what a great question. I want to tie into that question later. Remind me of the Jersey Turnpike in about, 20 minutes or so. We'll talk about the Jersey Turnpike and how it ties right back into your, again, your point. Such an important question. I remember sitting in a physics class, sophomore year of college, and this something science majors, physics majors. Same idea. Why can't you just add up and divide? I think we as American math educators do a terrible job in 4th grade because we teach you guys how to do averages in 4th grade. Because that's when you guys learn how to add and divide. Like, they can add and divide. Let's teach them how to do an average. Okay, how about you teach them how to do an average correctly, rather than just giving them a skill without any kind of guidance? What? That's the problem. And then they come to 243, or 105 in this case. We're going to do more of these, by the way. This idea of what's called a weighted average, we're getting into that soon. When we start talking about randomness and expectation, we start to understanding how life insurance policies work and how health insurance policies work and why you pay what you do for your health insurance and your life insurance. It's all about that kind of an average. But it's definitely not about simply adding up all the outcomes and dividing by how many, because the outcomes aren't always worth the same. That's the kicker, right? That's the kicker about averaging. It's like saying, I got a 50% chance of dying when I cross the street in Oregon. Well, you either do or you don't.
Right.
50%, right? Well, you laugh because it's ridiculous, but that's this taken to an extreme. You can't assume every single outcome is equally valuable. Is that fair? Hopefully, maybe. Okay, good. Great. That means such a good question. You've just kind of asked like the most important question of 243 in 105. But it's a big part of 105 too, so thank you, Tiffany. Hopefully it answered your question, I hope.